Hi everybody, so there is a company around called Holcomb Energy Systems, or HES, and they've been around for about, I think it's 13 or 15 years. It's quite a long time, and I've been aware of them for quite a long time, but I've been asked by a few folks about them, so I thought I would do a video about them. Now, as a complete aside, of course, Holcomb Energy Systems is spelt one way but pronounced another, and unfortunately for them, the pronunciation of it is very similar to the 19th century slang, which has supposedly comes from the theatre and combines hocus pocus and bunkum to give you hokum. It's a little unfortunate, but it's the name they have because of their founder, Dr. Holcomb. Now, the basic idea that they have for their generator is, well, I want to say intriguing, but intriguing isn't the right word. Actually, it really derives, I think, from a confusion we have, because there are four things that are essentially poorly understood. That's force, work, energy, and magnetism. And they themselves are fairly simple concepts, but actually applying them and combining them when you apply them becomes frighteningly complex. And because of that frightening complexity, very often what people say will sound kind of sensible, and then when you look at it, actually is kind of not very sensible. Because what we tend to forget when we combine things into a complex system is that every complex system is made up of simplicity. And if we look at the building blocks, the simplicity of that, then we'll know whether we're building our house on sand or not. So let's have a quick review of what these terms are. Force. Force, well, it's a real thing. It's what you apply to an object to get it to move, or to get it to stop, or to change its shape, or to change its speed, or to change its direction. Now, force is really important because we live in a real world with real objects, and we're a real object, and we want to manipulate those objects so that we can live, really, and have things. So we need to apply force on things all of the time. And the simplest thing, of course, is just to push something. You're applying a force and you're moving it, but that's all force actually is. There's nothing particularly mysterious about it. That's it. You push it, or you hold it, or you squeeze it, and you will do one of those 5 things. Now, when you apply a force on an object by whatever means, then of course you're going to move it. And that force times that movement is the amount of work that's actually done. So work done is another really basic concept. I mean, it does get a little bit more complicated because, if you're changing direction or speed, then there's a slightly different calculation to do. But it is just force times distance is what work is done. And work done, like force, is another real thing. If we want to see it, we just look in the world and we can see it and we can apply it. One of the big issues is when you can't see things, because when you can't see things, they become a little bit more mysterious. And one of the most mysterious things is energy, because you can't see energy. So what is energy? Now, work can also be defined as the energy transferred into an object to get it to displace or move. So if you like, energy can be seen as the ability to do work. Now, of course, to transfer energy, we use force. So force is the method by which we transfer energy into an object to achieve work done. Of course, there are lots of different kinds of energy and lots of different forces and different ways to transfer them. But that doesn't matter. It still doesn't affect the basic principles that we've just talked about. If you want to transfer energy, you do it by using a force that you apply on a thing to get work done, and those relationships remain constant and the amounts remain the same. And it doesn't matter whether it's a contact force like pushing or friction, or a non-contact force like gravitation or electrical or magnetic. The problem is, energy is invisible. It's not a real thing in the same way that an object is a real thing. And because we can't see it, of course, then there is a great deal of mystery around it. But essentially, that's actually all energy is. Or energy is a capacity to do work or an ability to do work rather than a real thing in itself. And of course, whenever something is hidden, it becomes more mysterious, more confusing. And of course, the same thing happens when we think about magnetism. Because with all the best will in the world, nobody actually understands what magnetism is. We understand how it behaves, we understand how we can utilize it, but nobody really understands what it is. And of course this leaves a whole load of shadows for things to hide in, because answering the question, what is magnetism, doesn't have a satisfactory answer. But we do know very clearly how magnets behave. One of the key behaviours of magnets as it relates to the Holcomb energy system is that property of reluctance. Magnetic reluctance is just like electrical resistance. Electrical current will flow down the path of least resistance. A magnet will take the path of least reluctance. So in the air, there's a great deal of reluctance for the air to take the magnetic flux. If I get a bit of steel, the reluctance in the steel is very much lower, and so the magnetic flux is directed into the steel. This is something that's used all the time in things like alternators for bending magnetic fields in crab claws. But that property, the following the path of least reluctance, is what's utilised in magnetic chucks. And the same idea is used in switched reluctance motors. So this is Holcomb's own explanation, taken from his website and his advertising material, about the basic principle of how his generator works. Now I may well get into trouble for this because of copyright reasons. I'm using his explanation, but I'm going to claim fair use and educational purposes and hope that keeps me free of any trouble. If not, I may have to take the video down. But this is what he showed and what he said when he was actually demonstrating why it worked. He built basically two transformers, one made of plexiglass and the other made of electrical steel, passed the same current through them and measured the flux, and claims that there's 4 times more flux in the electrical steel than there was in the plexiglass. But of course we've just looked at reluctance and we know that the density of the flux will be greater because more flux is being drawn into the steel, because the steel has less reluctance than it's going to be in the plexiglass. But density and amount aren't the same thing. The amount of flux remains the same, but you squeeze that same amount of flux into a smaller area, it becomes more dense. And this is true of every single motor and generator out there in the world that is using electrical steel, and they all do. So if it's true for his machine, it would be true for every single motor and generator that there is. They all should be producing 4 times the flux, but they're not, because all that electrical steel does is concentrate the flux and focus it in a point. And Dr. Holcomb took these results and created quite an interesting theory about how he thinks it might behave, involving unpaired electron spin around the atom of the iron in the electrical steel. But I would say we don't need a theory. We can take the basic building blocks that we've just looked at in this video and ask ourselves, well, is it likely to work? So he's used electrical steel in the same way that you would in any other generator to focus flux. So there is no more flux, it's the same amount of flux, it's just focused. It's a bit like a lever really, and a pivot. But will it actually create more force? Well, if it's not creating more flux, then it's not creating more force. If it's not creating more force, it can't do more work. And so it looks to me like we don't need to have a deep understanding of whatever theory the chap's on about. We just need a few basic principles to decide for ourselves whether this would be real or not. And those are always the key points to my mind. If you get hold of the very basic principles that we're looking at and apply them to whatever system you happen to be presented with, you can make a decision about whether you think it's likely to work or not. Anyway, I was asked to go through this. I hope it was of interest. Thank you very much for watching, and please do remember to like and subscribe.